Today, we live in a world insulated by technology. But step back into early prehistory, and human beings were entirely exposed. We had no thick hides, no sharp claws, and zero natural defenses against the heavy predators that shared our environment. To understand how we survived that hostile environment, we have to look at a discovery made in May 1863. A British geologist named Robert Bruce Foote was mapping the terrain near Pallavaram, a town outside Madras in southern India. While surveying the ground, Foote spotted this, the very first prehistoric hand axe ever unearthed in the Indian subcontinent. Someone, hundreds of thousands of years ago, had intentionally chipped away at its edges to form a deliberate shape. That single piece of shaped stone proved that early human intelligence was active in India long before recorded history. The find earned Foote the title of the father of Indian prehistoric archaeology. But this hand axe offers us something even more valuable. It gives us a starting point to track a significant cognitive and engineering progression across three distinct eras of human history. The story begins in the early Paleolithic Era. Early humans were heavily reliant on whatever raw materials were scattered around them, primarily heavy river pebbles and tough, coarse rocks like quartzite. Their engineering logic was brutally simple. To make a tool, they would take two heavy stones and violently smash them together until a rough, usable edge broke free. The result was heavy-duty equipment like choppers and cleavers. If you look at this early tool, you can see the thick core and blunt profile. These were essentially heavy weights meant for basic smashing and rough butchery. The fatal flaw of these early designs is that they forced the user to rely entirely on immense upper body strength. Worse, using them meant getting dangerously close to predators in hand-to-hand, close-quarters combat. In the early Paleolithic, survival was dictated almost entirely by physical brawn, rather than any kind of technological finesse. Around 100,000 BCE, humans realized striking a stone at a precise angle detached a razor-sharp flake. Discarding the heavy core, they kept the shatter. This transition was so distinct, archaeologist H.D. Sankalia classified the period as the flake culture. This new method produced a specialized toolkit of points, borers, and scrapers. Notice the refined surface and sharp tip on this triangular piece. It allowed early humans to perform detailed tasks like piercing animal hides and cleanly stripping meat from bone. To support this finer work, they upgraded their raw materials. They moved away from coarse quartzite and began sourcing highly durable, finer-grained stones such as chert, jasper, flint. By maximizing their cutting power while drastically reducing the weight of the tool, early humans executed their first true engineering optimization. By 40,000 BCE, the Upper Paleolithic began, a period where early humans focused on creating highly specialized and delicate equipment. Their technological peak was the double-edged blade. These three distinct stone pieces show just how delicate and narrow their proportions had become, featuring remarkably straight, razor-like edges. Because these blades were so small, they could be securely bound into lengths of wood or bone, a practice called hafting. Instead of holding a rock in their bare hands, humans were now building composite weapons like spears and arrows. This provided a critical tactical advantage: distance. For the first time, hunters could strike lethal, piercing blows against large predators from a safe position several yards away. The Upper Paleolithic shows us exactly when human intellect and engineering successfully overpowered the physical advantages of the natural world. This chart plots the three stages of tool evolution. As time progresses, physical weight drastically decreases, while sharpness and efficiency exponentially increase. This physical shrinkage maps directly to growing neurological complexity. Visualizing a sharp blade inside a blunt stone requires advanced spatial reasoning. That ancient trajectory of optimization, the drive to do much more with much less material, is the exact same engineering principle that drives today's modern technological world, from microchips to smartphones. The complex intelligence required to build our modern civilization was first awakened in the prehistoric struggle to shape a stone.